Welcome back to the tutorial. I'm going to solve a problem similar to the one I had done before, except this time you also have oxygen. There is a compound that contains carbon, hydrogen, and oxygen. And we are trying to find variables x, y, and z to say what's the empirical formula. This is burned or combusted in presence of oxygen, plenty of oxygen. Then again, you produce carbon dioxide and H2O. So you will have X moles of CO2 and you will have half as much hydrogen in H2Os as coefficient. Oxygen, do not worry about it. It's just going to support the combustion. But at very end, we have to find out how much oxygen we have, so we cannot ignore it. So let's go after the information we have. First, CO2. Remember, from all the carbons goes into CO2. So 1 mole of carbon is equal to 1 mole of CO2. Molar mass of CO2 last time we decided was 44. Atomic mass of carbon is 12. Now you have 3.04 grams of CO2, and let's find out how many grams of carbon we produce. So from this information, once you cross multiply 3.04 times 12 divided by 44 is value of x. So x happens to be 0.829 grams of carbon. I'm going to box it and save it. Let's go after H2O and then let's find out how much hydrogen we have. So for every H2O, remember you have twice as much hydrogen. Write it so you don't forget it. I have 1.24 grams of H2O. Remember, molar mass of H2O was 18. In every 18 grams of H2O, you have 2 grams of hydrogen. So for 1.24 grams, this is new proportionality. You can calculate what Y is. Y is amount of hydrogen in grams, which happens to be 0.138 grams. Okay, now we also have oxygen, so what I'm going to do is add the quantity of X and Y and subtract from 1.52 in order to tell how much oxygen we have. So grams of oxygen simply is equal to 1.52 minus X plus Y. So it's 1.52 take away 0.829 plus 0.138. And that will give you 0.553 grams of oxygen. So this came to life. Now I have carbon, hydrogen, oxygen. I have 0.829 grams of carbon, I have 0.138 grams of hydrogen, and 0.553 grams of oxygen. We have to convert them to moles, so we divide by their atomic masses. 12, hydrogen is 1, oxygen is 16. When we do this, carbon becomes 0.0691 mole, hydrogen becomes 0.138 moles, and oxygen becomes 0.0346 mole. Now we divide by the smallest to at least convert one of them into whole number 1. 0.0346 is the smallest among all three of them, so 0.0346, 0.0346, 0.0346. When you do this, you will see you have 2 carbons, you will have 4 hydrogens, and you will have 1 oxygen. So your final empirical formula is C2H4O, which is an aldehyde. In organic chemistry, you find out what aldehyde this is. So good luck until the next tutorial. I'm going to do the next problem similar to this, but I hope you pause me and you try to do it yourself and then just look at my calculations.